Welcome to myprojectbazaar.com. Now we are going to discuss about the product, a generative probabilistic model and discriminative extensions for brain lesion segmentation with application to tumor and stroke. Now we are going to discuss about the abstract for the process. In this paper present a method for detection of brain tumor from magnetic resonance imaging, that is the MRI image. MRI is basically used in the biomedical to detect and visualize the finer details in the internal structure of the body. This technique is basically used to detect the difference in the tissues, which have a far better technique as compared to the computed topography, that is the CT images. So this makes this technique a very special one for the brain tumor detection. CT images, which are used to ascertain the distance in tissues densities, and MRI provide an excellent contrast between various tissues of the body. Hence the pre-processing includes the image filtering, image skull stripping, etc. Then we have to extract the threshold from the image. The threshold segmentation is one of the simplest segmentation method. The input grayscale image is converted into an binary format by using these threshold limits only. After the binarization method, the segmentation is carried out by using the morphological technique SOM. Then we have to segment the tumor region from the other backgrounds. Then the severity of the tumor is calculated by using the classification method. In the classification method, we use the KNN classifier to detect whether the input is severe or normal or tumor region. Then the performance is measured by using the accuracy, sensitivity and specificity of the process. These are the parameters to estimate whether the process is efficient or not. Now we are going to discuss about the flow diagram for the process. This is the overall flow structure for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several images. At first, the input image is taken from the dataset. The pre-processing is carried out. In the pre-processing step, we have to done the skull stripping. The skull stripping is one of the most important process in the brain tumor segmentation, because first of all we have to extract the skull region presented in the input MRI image, then only we have to extract the tumor region from the other backgrounds. After extracting the skull region from the input image, we have to detect the threshold value from the image. Hence, by using this threshold value, we have to convert the normal grayscale image into an binarized image. That is, the image consists of only two values, that is the pixel value as 0 and the pixel value as 1s. After the binarization of the image, the morphological is carried out to detect the tumor region, as well as the morphological is applied to segment the tumor region from the other backgrounds. After extracting the tumor region, the segmented result is carried out to the detection part. In the detection part, we have to detect whether the tumor is normal or abnormal, or the tumor is in the increasing order or not. After the detection of the tumor, we have to justify the process by using the accuracy estimation. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. If you want to execute the code means, just right click in the mainfile.m and select the option run. Now you can see the dataset folder presented here. Now open the dataset folder and select any one image from the dataset. After the selection of the input image from the dataset, the process will be automatically done. Now we will discuss the result one by one. This is the input image which we have taken from the dataset. After the input image taken from the dataset, the resized image is shown here. Then the input image and the filtered image is shown in the subplot. Now for the skull removal process, here we load the input image, then we take the histogram of the process, then the binarized image is shown in the subplot 3, then the cleaned binary image is shown in the subplot 4. In the subplot 5 describes the skull removed binary image. Here the ones regions represent the skull removed brain image and the other background remains will the background. After the skull removal process, the tumor detection will be carried out. This is the result for the tumor detection. Here the tumor region will be the ones region and the other backgrounds will be eliminated. Here the contour detection is used to detect the tumor region from the image. Then the original pixel is replaced instead of the white pixels. Then the pattern is extracted from the tumor region. Here we use the local binary pattern for the feature extractions to extract the pattern regions. Then the values of the patterns is shown in the table format. Then the histogram value is taken then as plotted as a table. Then we have to select the ground truth for the image. The output segmentation result and the ground truth is combined, then compared to each other, then the tumor decreased result is shown in the message box. After that, the performance estimation is estimated and then plotted in the bar graph. Here the accuracy, error rate, sensitivity and specificity values are plotted in the bar chart format. Now this is the final result and the performance measures are shown. Both the comparison between the existing and the proposed results will be shown here.
Thanks for watching this video.